There is a question that has been sitting at the edge of human curiosity for as long as people have been turning off lights and lying in the dark, wondering about the universe. It sounds like something a child would ask. It sounds almost too simple to be worth serious attention. And yet, when physicists encounter it, when they sit with it long enough to follow it all the way down to where it actually leads, it dismantles assumptions so deeply embedded in the human mind that most people never even knew the assumptions were there. The question is this: if light has a speed, does darkness have one too? Right now, light is moving past you, not metaphorically, physically. Photons are crossing this room, passing through your window, streaming down from every artificial source in your environment at a speed so precise that since 1983, the scientific community stopped measuring it and started defining the meter itself by it. 1 meter is the distance light travels in 299,792,458th of a second. The measuring stick of human civilization is built on the back of a photon. The speed of light is not a measurement anymore. It is a definition, a fixed point, the most precisely known quantity in all of science. 299,792 kilometers per second, 670 million miles per hour, the fastest anything in this universe will ever move. Every physicist on Earth agrees on this number. It has been confirmed by spinning cogwheels and rotating mirrors and laser interferometers and atomic clocks and the timing of spacecraft signals across interplanetary distances. It has been verified by the motion of distant quasars and the behavior of particle accelerators and the precise predictions of quantum electrodynamics, the most accurately tested theory in the history of human thought. Every method, every instrument, every decade of measurement converges on the same number. So the question seems natural, almost inevitable. If light has a speed that is this well-defined, this absolute, this foundational to the architecture of the universe, then what about its opposite? When you turn off a lamp and the room goes dark, something happened. Something changed. The room was bright, and now it is not. If light traveled to fill that room, did darkness travel to replace it? Did it rush in from the corners at some measurable velocity? Did it flood through the doorway, descend from the ceiling, advance from the walls? And if it did, how fast did it move? Faster than light, slower, exactly the same, faster than anything else in the universe. Is darkness the one thing that outruns the photon? Your brain right now is generating an answer to that question. It may be doing it consciously, or it may be doing it below the level of awareness, but something in the way human cognition works is reaching for a response. And whatever that response is, it almost certainly contains an assumption so natural, so obvious, so baked into the way humans have experienced the alternation of light and dark since birth, that questioning it feels unnecessary. The assumption is that light and darkness are symmetric, that they are two sides of the same phenomenon, that if one has a speed, the other should have a corresponding speed, that if one is a thing, the other is also a thing, that the room is filled with light, and when the light leaves, it is filled with darkness, and that darkness arrived the way light arrived, as something traveling, something moving, something with a physical identity that can be tracked and measured and given a number. That assumption is wrong, not slightly wrong, not wrong in a way that requires minor correction. Wrong in a way that, once you see it clearly, changes how you understand not just this question but the nature of physical reality itself. Wrong in a way that physicists have spent centuries working out the full implications of, and that even now, with quantum field theory and general relativity and experimental confirmations at every scale from subatomic to cosmological, continues to reveal new layers of strangeness the further you follow it. The answer to whether darkness has a speed is not a number. It is not faster than light, or slower than light, or exactly equal to light. The answer is that the question, as your brain initially frames it, does not apply. And understanding why it does not apply requires understanding something that seems even more basic. What light actually is, not in the loose sense that everyone already knows. Electromagnetic radiation, visible wavelengths between roughly 380 and 700 nanometers, the thing that comes out of the sun and light bulbs and flames. But in the deep sense, What is a photon? Where does it come from? Why does it have the speed it has? Why can it not go faster or slower? And what, precisely, is missing from a dark room that was present in a bright one? That story begins inside a star. Somewhere in the core of the sun right now, something violent is happening at a scale that resists ordinary comprehension. 600 million tons of hydrogen are being compressed together every single second under pressure so extreme that the atoms themselves cannot hold their structure. Electrons are stripped away. Protons that would normally repel each other with enormous electromagnetic force are pressed so close together that the strong nuclear force takes over and fuses them into helium nuclei. In that fusion, a small fraction of mass vanishes. It does not go anywhere in the ordinary sense. It converts directly into energy according to the equation that sits at the center of 20th century physics. 4 million tons of matter are annihilated every second inside the sun, transformed into pure radiation. That radiation begins as gamma rays, photons of such extreme frequency and energy that they would obliterate any biological structure they encountered. But these photons do not escape immediately. The solar interior is so dense, so packed with charged particles, that each photon travels only a fraction of a centimeter before being absorbed by an atom, re-emitted in a random direction, absorbed again, re-emitted again. This process repeats trillions upon trillions of times. A single photon undergoes a random walk through the solar interior that takes, by current estimates, somewhere between 10,000 and 170,000 years to complete. A photon born in the core of the sun today will not reach the surface until long after human civilizations have risen and collapsed many times over. Then it breaks free. At the precise moment a photon escapes the outer atmosphere of the sun and enters the vacuum of open space, something extraordinary happens. It does not accelerate gradually. It does not build up speed over time. It does not require a runway or a push. The instant it is in vacuum, it is moving at 299,792 kilometers per second. Not approximately, exactly. Because that is not a speed the photon achieves. That is the only speed a photon is capable of traveling in a vacuum. It has no other gear. It cannot go slower. It cannot go faster. From the moment of its creation to the moment of its destruction, it exists at exactly that velocity. Not more, not less, not ever. This is not a coincidence. It is not an accident of nature. It is a structural fact about what photons are and what the vacuum is. The speed of light is not something that photons happen to reach. It is something the vacuum demands. And to understand why, you have to understand what light actually is at the level of fundamental physics, which is where this story has to go before it can come back to the question of darkness and give you an answer that actually holds up under examination. Because the answer that holds up is stranger than most people expect, and it does not just tell you something about darkness, it tells you something about causality, about the architecture of time, about why the universe has a history instead of existing all at once in a single frozen instant, about why you can know things, communicate things, affect things at a distance at all, about why reality has a before and an after instead of a simultaneous everything. All of that is in the question about darkness, hidden underneath what sounds like a simple curiosity about what happens when you flip a switch. Most people ask the question and expect a number as the answer. What they get, if they follow it far enough, is a glimpse of the operating system of the universe, the deepest mechanism by which causes connect to effects across the fabric of space-time. And the reason darkness cannot participate in that mechanism, the reason it has no speed, no direction, no physical identity of any kind, turns out to say more about the nature of reality than almost any positive fact about light itself. Darkness is not the enemy of light. It is not its counterpart. It is not its competitor or its twin. What darkness actually is, and what that reveals about the universe you inhabit, is a revelation that has been sitting inside one of the most ordinary questions a human mind can ask, waiting for someone patient enough to follow it all the way down. Tonight, we follow it all the way down. This is the kind of science that does not ask you to memorize facts. It asks you to update the picture you carry of what exists. And updating that picture, once you have done it, is the kind of thing that changes how a dark room feels at 3 in the morning, how the space between stars looks when you step outside on a clear night, how you understand the silence that fills the universe between the rare, remarkable, almost miraculous moments when a photon crosses the void and reaches something that can receive it. If that is the kind of science that finds you tonight, then you are in the right place. Nocturnal space exists for exactly this, for the questions that sound simple and go somewhere extraordinary. Subscribe if you have not. Turn on notifications so nothing passes you by while you are sleeping. And if this video found you at the end of a long day, when the lights are low and the room is quiet and the dark feels very present around you, then settle in. Because what the dark actually is and what it cannot be is where we begin. For most of human history, light was treated as something so fundamental, so immediate, so obviously present the instant it was needed, that the question of what it actually was barely seemed worth asking. You open your eyes and the world is there. You strike a flint and the spark illuminates. You step into sunlight and warmth arrives with it. Light behaved like a given, a background condition of existence rather than a phenomenon requiring explanation. It was everywhere it needed to be, apparently without effort, apparently without time, apparently without any of the properties that would make it an object of scientific inquiry rather than simply the medium through which everything else was seen. That intuition turned out to be one of the most consequential mistakes in the history of human thought. And dismantling it, piece by piece, across 3 centuries of increasingly precise and increasingly strange experiments, produced a picture of light so different from the one intuition suggests that even now, with the full framework of quantum field theory and special relativity available, it retains the capacity to stop a thinking person mid-sentence. The first serious attempt to measure whether light had a speed at all came in 1638, when Galileo Galilei stationed an assistant on a hilltop roughly 1 mile away, gave him a lantern, and instructed him to uncover the lantern the moment he saw Galileo's light flash. Galileo would then measure the delay between his own flash and the return signal. The experiment failed completely, not because Galileo was careless, but because light is so fast that human reaction time swamps any possible measurement over a distance of 2 miles. Galileo concluded that light was either instantaneous or extraordinarily fast. He was right about the second option, but he had no way to know how right. The breakthrough came from an unexpected direction 38 years later. In 1676, a Danish astronomer named Ole Rømer was working at the Paris Observatory, carefully timing the eclipses of Io, one of Jupiter's 4 large moons. Io orbits Jupiter with clockwork regularity, ducking behind the giant planet and reappearing on the other side in a cycle of roughly 42.5 hours. Rømer had been logging these eclipses for months, building precise tables of predicted times, but the predictions kept drifting. When Earth and Jupiter were close together in their orbits, the eclipses arrived a few minutes early. When Earth was on the far side of its orbit, farther from Jupiter, the eclipses arrived late. Rømer realized the pattern could not be explained by any irregularity in Io's orbit. What was changing was the distance light had to travel. When Earth was closer to Jupiter, the light from each eclipse had a shorter path and arrived sooner. When Earth was farther, the light needed more time. The eclipses themselves were perfectly regular. The information about them, carried by photons across interplanetary space, arrived early or late depending on the gap between the 2 planets. Rømer had established something that would take another 2.5 centuries to fully understand. Light traveled at a finite speed. The universe did not communicate instantly. It communicated at a specific, limited rate. 2 centuries of increasingly clever experiments followed. In 1849, the French physicist Hippolyte Fizeau directed a beam of light through the gap between teeth on a rapidly spinning cogwheel, aimed it at a mirror 8.5 kilometers away, and caught the reflected light through the next gap in the spinning wheel. By adjusting the wheel's rotation speed until the returning light passed cleanly through, he could calculate how long the round trip had taken. His result was approximately 5% above the modern value. Imperfect, but astonishing for a tabletop experiment measuring the fastest phenomenon in nature. Léon Foucault refined the technique. Albert Michelson dedicated decades to perfecting it. By the mid-20th century, laser interferometry and atomic clocks had pushed the measurement to extraordinary precision, with uncertainties measured in fractions of a meter per second. Every refinement confirmed the same number, and that consistency across so many independent methods, so many different instruments, so many different centuries and countries and approaches eventually led the scientific community to do something radical. They stopped measuring the speed of light and started defining units of length by it. The meter ceased to be an independent standard. It became a derivative of the speed of light. This was not bureaucratic convenience. It was a statement of profound physical confidence. The constancy of C was trusted more than any physical artifact or measurement technique. The speed of light had become bedrock, but knowing that light had a speed told only half the story. The deeper question, the one that would take far longer and prove far stranger, was what light actually was. Isaac Newton believed light was a stream of tiny particles. He called them corpuscles, minute bodies emitted by luminous objects, and his authority carried such weight that the theory dominated for more than a century. The particle theory explained reflection neatly, corpuscles bouncing off surfaces like tennis balls off a wall, but it struggled with something that careful observers kept noticing. When light passed through a narrow slit or around a sharp edge, it did not behave like a stream of particles. It spread, it bent, it created patterns of alternating brightness and darkness that looked nothing like what a particle should produce. In the early 19th century, Thomas Young's double-slit experiment settled the question decisively, or so it seemed. When coherent light passed through two closely spaced slits, it produced an interference pattern on a distant screen. Alternating bands of brightness and darkness arranged with mathematical precision. This pattern could only be explained if light waves from the two slits were overlapping, reinforcing each other where crests met crests and canceling where crests met troughs. Particles could not produce this. Waves could. The wave theory triumphed. But waves need a medium. Sound waves require air. Water waves require water. If light was a wave, what was it waving in? Scientists hypothesized the luminiferous ether, an invisible substance filling all of space through which light oscillated. The ether had to be simultaneously rigid enough to support the extremely high-frequency vibrations of light and tenuous enough to offer no resistance to the motion of planets through it. The contradictions in this picture were obvious, but no alternative offered itself, and so the ether endured in the theoretical literature for decades. In 1887, Albert Michelson and Edward Morley designed what should have been the definitive test of the ether's existence. If Earth moved through a stationary ether in its orbit around the Sun, then light traveling in the direction of Earth's motion should move at a slightly different speed than light traveling perpendicular to it, just as a swimmer moving with a current covers distance faster than one swimming across it. Using an interferometer of extraordinary precision, they looked for this speed difference. They found nothing. No matter what direction they measured, light traveled at the same speed. The ether, if it existed, had no detectable effect. The null result baffled the physics community for nearly 2 decades. The resolution came not from experiment but from theory, and the theorist who provided it was not looking for a solution to the ether problem. He was asking a different question entirely, one that seemed almost philosophical rather than scientific. What would it mean for the laws of physics to look the same to all observers moving at constant velocities relative to each other? James Clerk Maxwell had already done the mathematical groundwork. In the 1860s, working in Edinburgh and later London, Maxwell unified electricity and magnetism into a single coherent theory, described by 4 equations of extraordinary elegance. The equations described how electric charges produce electric fields, how moving charges produce magnetic fields, how changing magnetic fields induce electric fields, and how changing electric fields induce magnetic fields. The 4 interlocked, each feeding into the others in a self-reinforcing cycle. When Maxwell solved his equations for empty space, with no charges or currents present, something fell out that he had not put in. The equations predicted the existence of self-sustaining waves, oscillating electric and magnetic fields propagating through the vacuum at a speed determined entirely by 2 constants: the electric permittivity of free space and the magnetic permeability of free space. These constants describe how strongly the vacuum responds to electric and magnetic fields, respectively. Maxwell calculated the speed these constants implied and found it matched the measured speed of light almost exactly. The implication was staggering. Light was not a separate phenomenon requiring its own explanation. It was an electromagnetic wave, identical in nature to what would later be recognized as radio waves, microwaves, infrared radiation, ultraviolet light, X-rays, and gamma rays. All of these were oscillating electric and magnetic fields propagating through space at the same fundamental speed. They differed only in wavelength and frequency. Visible light occupied a narrow band in the middle of an enormous spectrum. The universe was filled with electromagnetic radiation of every conceivable frequency, and all of it traveled at c. But the deeper revelation was this. The speed of light was not something light happened to achieve. It emerged directly from the properties of empty space itself. The vacuum has a specific electric permittivity and a specific magnetic permeability. Multiply them together. Take the inverse. Take the square root. The result is a speed. The speed of light is baked into the structure of the vacuum. It is not a speed that light reaches. It is the speed the vacuum demands of any electromagnetic disturbance propagating through it. Then came Einstein. In 1905, a 26-year-old patent clerk in Bern, Switzerland, published a paper that would dismantle 3 centuries of assumptions about space and time. Einstein did not discover that the speed of light was constant. Maxwell's equations already implied it. What Einstein did was take that constancy with absolute seriousness and follow it wherever it led, regardless of how bizarre the consequences became. His starting postulate was simple. The speed of light in a vacuum is the same for all observers, regardless of how fast they are moving or in what direction. That postulate sounds reasonable. Its consequences were catastrophic for classical physics. If c is the same for everyone, then something else must give when observers move relative to each other. That something turned out to be space and time themselves. Distances contract in the direction of motion. Clocks tick slower for moving observers. Events that appear simultaneous to one observer occur at different times for another. Mass increases as velocity increases, requiring ever more energy to accelerate further. And at the speed of light itself, the equations break down entirely. A massive object approaching c would require infinite energy to reach it. The speed of light is not a practical barrier. It is a mathematical wall embedded in the structure of reality. But Einstein's framework revealed something more profound than a cosmic speed limit. It revealed what that limit actually governs. The speed of light is not merely the velocity at which electromagnetic radiation happens to travel. It is the maximum speed at which any causal influence can propagate through space-time. No force, no signal, no interaction of any kind can outrun c. Gravity propagates at the speed of light. Changes in electromagnetic fields propagate at the speed of light. If you disturb something here, the earliest that disturbance can affect something over there is the time it takes light to travel the distance between them. This is not an engineering limitation. The universe itself does not transmit causal connections faster than c. The speed of light is the universe's mechanism for keeping events in order, for ensuring that causes always precede their effects. Remove that mechanism, allow causal signals to travel at infinite speed, and the concepts of before and after dissolve. Effects could precede causes. Messages could arrive before they were sent. Time itself would lose its directionality. And from a photon's own perspective, something even stranger emerges. Special relativity predicts that as an observer approaches the speed of light, time dilates. Clocks tick slower. At exactly c, time dilation becomes infinite. Time stops entirely. A photon emitted from a star 26,000 light-years away experiences no elapsed time during its journey. From its frame of reference, emission and absorption are the same event. The photon's entire existence, its creation inside a stellar furnace and its death against a human retina on a dark night, happens in a single instant of its own non-existent clock. It crosses the galaxy in 0 seconds of its own time. We are not dealing with an ordinary phenomenon. We are dealing with a massless quantum of electromagnetic energy that exists at one and only one speed, determined by the fundamental properties of the vacuum, carrying energy and information across space-time at the maximum rate the universe permits. A photon cannot slow down in a vacuum any more than you can choose not to exist. The instant it is created, it is moving at c. The instant it is absorbed, it ceases to exist. Between those two moments, it is perpetual motion at the one velocity reality allows. That is what fills a bright room. Not light in a vague sense. Photons. Discrete quanta of electromagnetic energy, each one traveling at the only speed available to it, each one carrying a specific amount of energy determined by its frequency, each one a tiny causal connection between the source that created it and the surface that will eventually absorb it. And when the source stops creating them, when the lamp filament goes cold and no new photons are emitted, what fills the room is not a new substance that arrived to replace the old one. Something stopped arriving. The room did not receive darkness, it lost light. And the difference between those two descriptions is not semantic. It is the difference between a physical event and the absence of one, between a thing that exists and a condition that remains when a thing stops existing. That distinction, obvious as it sounds when stated plainly, is one that human cognition resists with remarkable stubbornness. And understanding why the brain resists it and what it means that it does is where this story has to go next. Because the physics of what darkness actually is, or more precisely what it is not, goes deeper than the simple observation that it is an absence. It goes all the way down to the question of what kinds of things the universe contains and what kinds of things it merely describes. And the answer to that question, when you reach it, changes not just how you think about dark rooms and shadows and the night sky, but how you think about the nature of reality itself. The room is dark now, and we are only just beginning to understand what that means. Imagine you are sitting in a concert hall, the kind of place where the architecture itself was designed to move sound, where the ceiling curves in specific geometries calculated to carry a violin's upper harmonics to the back row without losing a single frequency, where the seats are upholstered in a material chosen partly for how it absorbs the frequencies that would otherwise create unwanted resonance. The orchestra is mid-performance. 120 musicians producing sound simultaneously, pressure waves radiating from every instrument, colliding and interfering with each other in patterns of almost incomprehensible complexity. All of it resolving in your ears into something coherent and moving and real. Sound is a physical phenomenon. It has frequency, amplitude, wavelength. It carries energy measurable in joules. It exerts pressure on the surfaces it strikes, pressure precise enough to rupture an eardrum at sufficient intensity, gentle enough at lower levels to cause the tiny bones of your inner ear to vibrate in patterns your brain translates into music. You can record sound on tape. You can encode it in digital ones and zeros. You can broadcast it across the planet through satellite signals. You can reconstruct it from mathematical equations. Sound has a rich physical identity with properties you can quantify, predict, and manipulate with extraordinary precision. Now the conductor raises the baton for the final time. The last chord builds, swells, reaches its peak. Then the baton drops. Every musician lifts bow from string, pulls mouthpiece from lips, releases drumstick from head simultaneously. The sound decays. The reverb trails off as the last reflections are absorbed by the walls and seats and the clothing of the audience. And then, silence. Here is the question. Did silence arrive? Did a wave of quiet radiate outward from the stage at some measurable velocity, sweeping across the concert hall row by row, silencing each seat in sequence as it passed? Is silence a thing that traveled from the musicians to your ears, the way the music did? Did it have a speed? Could you, in principle, build an instrument sensitive enough to measure how fast the silence propagated from the stage to the back wall? The answer is so obvious it barely needs stating. No. Silence did not travel anywhere. Silence has no speed, no frequency, no wavelength, no energy. Nothing radiated from the stage when the musicians stopped playing. The musicians simply stopped producing sound waves, and the existing waves dissipated through absorption by walls, seats, clothing, and air molecules. What remained was the absence of organized pressure fluctuations. The air was still there. Molecules were still bouncing around at thermal velocities. But the coherent vibrations that constitute sound had ceased. Silence is the word we use for that cessation. It is a description of a condition, not a description of a substance. Nobody struggles with this when it comes to sound. Nobody asks what the speed of silence is. Nobody wonders whether silence is made of anti-sound particles that rush in to fill the void left behind by departing noise. Nobody imagines a wave of quiet sweeping across the hall at some fraction of the speed of sound. The idea is immediately, obviously, almost laughably wrong. Silence is nothing. It is the absence of something. It does not travel because it is not a thing that can travel. Darkness is identical to silence in every single physical respect that matters. This is not an analogy. It is not a helpful comparison designed to make an unfamiliar concept easier to grasp. It is a statement of the actual physical relationship between light and darkness, which mirrors exactly the relationship between sound and silence. Darkness is not a substance. It is not a particle. It is not a wave. It is not a field. It is not a force. It carries no energy. It exerts no pressure. It has no wavelength, no frequency, no momentum, no spin, no polarization. It does not propagate through space. It does not interact with matter in any way that physics can describe. It does not appear as an entry in any catalog of physical entities ever compiled by any physicist working in any tradition in the entire history of the discipline. Darkness is a word, a human invention, a label applied to the condition of insufficient photons in a region of space to stimulate visual perception or trigger electromagnetic detection. That is the complete physical description of darkness, a deficit, an absence, a nothing with a name. Consider the standard model of particle physics, the most successful scientific theory ever constructed, accounting for every known fundamental particle and every known fundamental force with a precision that extends to 12 decimal places in some predictions. It describes quarks in 6 flavors, leptons in 3 generations, the gauge bosons that mediate the fundamental forces, the photon for electromagnetism, the gluons for the strong force, the W and Z bosons for the weak force, the Higgs boson that gives mass to other particles, neutrinos, antiparticles for every matter particle. The catalog is extraordinarily detailed. It has been verified by experiments at particle accelerators on multiple continents over multiple decades. It does not include a darkness particle. There is no darkon. There is no shadow boson. There is no antiphoton that constitutes the substance of darkness, that fills dark rooms the way photons fill bright ones, that travels through the air when lights are extinguished, carrying the property of visual absence from one location to another. If darkness were a physical entity, it would need to appear somewhere in this framework. Matter and energy do not exist outside the Standard Model's accounting system, without leaving experimental signatures that physicists would have detected long ago. The absence of a darkness particle from the catalog is not an oversight. It is not a gap waiting to be filled. It is a reflection of the fact that there is nothing to catalog. This seems clear enough when stated plainly, and yet something about the human experience of darkness resists this clean categorization with remarkable persistence. Walk into a pitch-black room, and your body does not respond as though it has simply registered the absence of something. It responds as though something tangible surrounds you. Your pupils dilate to their maximum aperture, straining to collect photons that are not arriving. Your skin prickles. Your heartbeat accelerates. Your brain shifts into a heightened state of alertness, amplifying auditory and tactile signals to compensate for the lost visual channel. Every hair on your arm is reporting. Every sound becomes significant. Every shift in temperature carries meaning. The emotional weight of darkness is entirely real, even though darkness itself is not a thing. This perceptual bias runs so deep that it is embedded in human language and mythology at the most fundamental levels. Darkness falls. Shadows creep. Night descends. Gloom gathers. Every one of these phrases treats darkness as an active agent, a substance that moves and arrives and acts in the world. Ancient civilizations built entire theological systems around the opposition between light and dark as equal and opposite cosmic forces. The Zoroastrians framed existence as a battle between the Lord of Light and the Lord of Darkness, two entities of equivalent power locked in eternal struggle. Egyptian mythology centered on the sun god's nightly journey through the underworld of dark. Norse cosmology began in a primordial darkness preceding creation. These frameworks feel intuitively correct because human experience presents light and dark as symmetric. Day and night alternate. Illuminated and shadowed spaces coexist in every landscape. The brain processes both states as positive experiences, as things you perceive, rather than processing one as a thing and the other as the absence of that thing. Physics does not care about human intuition. Physics describes what exists and how it behaves. And on this point, physics is unambiguous. The symmetry between light and dark is an illusion manufactured by the human visual system. Light is a physical phenomenon with measurable properties. Darkness is a perceptual state corresponding to the absence of that phenomenon. They are not two substances occupying a room in alternation. They are a substance and the lack of that substance. The relationship is fundamentally, completely, and irreversibly asymmetric. To make this asymmetry vivid, consider the properties you can assign to light: wavelength, frequency, energy, momentum, polarization, speed, direction of propagation, spin, angular momentum. Every single one of these is measurable, quantifiable, and governed by precise equations. You can calculate the energy of a photon from its frequency using Planck's constant. You can determine its momentum from its wavelength. You can describe its polarization state as linear, circular, or elliptical. You can predict its behavior as it passes through a lens or reflects from a surface or diffracts around an edge. Light has a rich, detailed, multidimensional physical identity. Now, attempt to assign properties to darkness. What is the wavelength of darkness? There is no answer, because wavelength describes an oscillation, and darkness does not oscillate. What is the energy of darkness? Zero. Or more precisely, the question does not apply because darkness is not an entity that carries energy. What is the momentum of darkness? Same problem. What is the polarization of darkness? The concept does not translate. What is the frequency of darkness? There is nothing to have a frequency. Every property you attempt to assign to darkness turns out to be either zero or undefined, not because darkness is an exotic phenomenon that physics has not yet learned to characterize, but because darkness is not a phenomenon at all. It is the descriptor applied when the phenomenon of light is absent. Trying to assign physical properties to darkness is a category error of the most fundamental kind. It is like asking how much a vacuum weighs, or what shape Wednesday is, or how loud emptiness gets when you turn up the volume. The question applies a concept to a domain where the concept has no meaning. A useful parallel comes from thermodynamics. Heat is a form of energy, specifically the transfer of thermal energy between systems at different temperatures, driven by molecular kinetic energy. When molecules move faster, a substance is hotter. When they move slower, it is cooler. Heat can be measured in joules, tracked as it flows from hot objects to cooler surroundings, and described with extraordinary precision by the laws of thermodynamics. Heat is a physical phenomenon. Cold is not. There is no particle of cold. No coldness field permeates space. When something cools down, it is not because a substance called cold arrived and displaced the heat. It is because heat energy left the object, transferring to the surroundings through radiation, conduction, or convection. The object now contains less thermal energy than before, and we describe its new state as cold. But cold is not a thing. It is a condition, a description of reduced energy, a word for what remains when heat is absent. Physicists spent centuries being confused about this exact distinction. Before the development of thermodynamics, a theory called caloric proposed that heat was an invisible fluid that flowed between objects. Hot objects contained a lot of caloric fluid. Cold objects contained little. The theory was elegant, internally consistent, and completely wrong. Heat turned out to be not a substance but a process, a transfer of kinetic energy between particles. The caloric model was a category error that treated a process as a thing. Darkness invites the identical category error. The urge to treat it as a substance, a thing that fills space when light departs, is understandable. Darkness occupies space in your visual field. It surrounds objects. It seems to have depth and texture and almost physical weight. But all of these impressions are artifacts of how your brain processes the absence of visual information. The depth you perceive in darkness is your visual cortex interpolating over a region where it has no data. The texture is noise in your retinal signal amplified by a brain desperate for patterns it can interpret. Darkness is your brain's response to receiving nothing. It is not a feature of external reality. It is an internal construction generated in the absence of input. There is a name for this cognitive tendency in psychology: reification, the brain's habit of treating abstract concepts and genuine absences as concrete, tangible things. We reify darkness constantly and automatically, beneath the level of conscious awareness, because evolution built that tendency into us so deeply that it operates before rational thought can intervene. And the reason evolution built it in is not mysterious. Organisms that treated darkness as a potential presence, as a condition requiring heightened vigilance and altered behavior, survived at dramatically higher rates than organisms that dismissed it as a neutral absence. In an environment where predators hunt at night, where threats become invisible in shadow, where the absence of visual information is itself dangerous, treating darkness as a thing, as something real and active and worth responding to, is the difference between surviving and not surviving. The brain that says darkness is something to take seriously passes its genes forward. The brain that says darkness is merely the absence of photons and relaxes accordingly gets eaten. 3.5 billion years of biological evolution do not optimize for physical accuracy. They optimize for survival. And for survival, darkness absolutely is something. It is a condition of danger, a state demanding response, an environment requiring specific behaviors to navigate. The brain learned to treat it as real because treating it as real kept organisms alive. That evolutionary legacy walks with every human being into every physics classroom and every late-night conversation about the nature of reality. It is why the question of whether darkness has a speed feels meaningful rather than malformed. It is why the intuition that darkness must be something, must have properties, must travel and arrive and behave like a substance, persists even in people who intellectually understand that light is a particle and darkness is its absence. Bridging that gap between what evolution trained us to believe and what physics has established to be true is one of the quiet achievements of scientific thinking. And standing on the other side of that bridge, with the real physical picture clearly in view, changes something about how the dark feels. Not because darkness becomes less real in experience. The heightened alertness, the prickling skin, the amplified sounds, all of that remains exactly as vivid as it always was. But because understanding what darkness actually is, understanding that it is not a substance that arrived, but a condition that remained when something departed, opens a question far more interesting than the one it replaces. If darkness is nothing, what is it that departed? What exactly happens at the level of individual photons, in the moments when a bright room becomes a dark one? What is the physical sequence of events that constitutes the transition from light to dark? And what does that sequence tell us about the real relationship between the speed of light and the apparent speed of darkness? That is exactly where we are going next. And the answer is one of those rare cases in physics where the simple version and the deep version point in exactly the same direction, but the deep version reveals something that the simple version could not have prepared you for. If this is the kind of thinking that finds you at the end of a long day, that quiet excavation of the obvious until something unexpected appears underneath, then Nocturnal Space is built for you. Every video on this channel starts with a question that sounds simple and follows it somewhere most people never go. Subscribe. Turn on notifications. The universe has more of these questions than any single night can hold, and we are working through them one at a time. The room is still dark. The physics is about to get stranger. There is a moment that happens billions of times every second across the surface of this planet, in homes and offices and hospital corridors and late-night kitchens, a moment so ordinary that it registers as nothing, a reflex, a gesture performed without thought or attention. A hand reaches for a switch. A finger applies pressure. A circuit opens, and a room that was filled with light becomes dark. That transition from bright to dark feels instantaneous. It feels simultaneous across the entire room. The light does not fade from one corner first and then spread the darkness outward. It does not dim gradually like a sunset. It stops. The room is bright, and then with no perceptible interval, it is dark. Your brain processes the change as a single event with no internal structure, no sequence, no detectable duration. But something happened in that transition. Something physical. A sequence of events unfolded at a scale too fast for any human sense to resolve, governed by the same physics that determines how stars live and die, and how the universe transmits information across the void between galaxies. And examining that sequence in detail, slowing it down to the time scale where photons are individual actors with individual trajectories and individual fates, dissolves the question of darkness having a speed more completely than any abstract argument could. Consider the simplest possible version of the scenario. A single lamp sits at the center of a room that is 5 meters across in every direction. The lamp is on. It has been on long enough that the room has reached a steady state, meaning the population of photons bouncing between surfaces has stabilized at a constant level maintained by the continuous stream of new photons from the source. The walls, ceiling, and floor reflect some fraction of arriving photons and absorb the rest. At any given moment, the room contains an enormous number of photons in transit between surfaces, each one traveling at the speed of light, each one carrying a tiny quantum of energy that will eventually be deposited as heat when it is finally absorbed. The lamp emits photons in all directions simultaneously. A photon leaving the lamp in the direction of the nearest wall, 5 meters away, covers that distance in approximately 16 nanoseconds, 16 billionths of a second. So fast that to any human observer standing in the room, the space between the lamp and the wall appears to fill with light the instant the lamp switches on, with no detectable travel time whatsoever. The room is simply bright, uniformly and immediately, because the transit times involved are 11 orders of magnitude faster than human perception can resolve. Now the circuit opens. The lamp switches off. At the precise moment the filament cools and ceases emitting, a specific physical event has occurred. A source has stopped producing particles. That is the complete description of what happened. No new substance was created. No signal was broadcast into the room announcing that darkness was coming. No wave of any kind propagated outward from the lamp. A process that had been running continuously simply stopped. The lamp was a photon factory, and the factory closed. But the photons already in flight do not know this. They cannot know this. A photon moving through the room at the speed of light has no mechanism for receiving information about what the source that created it is now doing. It is an independent particle on an independent trajectory. It will continue in its current direction, at its current speed, until it strikes a surface and is absorbed, exactly as it would have done if the lamp were still on. The lamp's shutdown affects only the production of new photons. It has no retroactive effect on the photons already traveling. So in the moments immediately following the lamp's shutdown, the room still contains all the photons that were in transit at the moment the switch was thrown. The photon that was closest to the far wall when the switch was thrown will reach that wall in less than 16 nanoseconds and be absorbed. The photon that was halfway across the room will reach its destination in about 8 nanoseconds. The last photon emitted by the lamp, the one produced at the precise final instant before the filament went cold, is already moving away from the lamp at the speed of light. It will reach the nearest surface in 16 nanoseconds. Any photons that were bouncing between walls at the moment of shutdown will complete their current trajectories, strike surfaces, be partially reflected, continue to the next surface, and eventually be absorbed. Each of these photons is traveling at sea. Each of them is carrying out the final legs of journeys that began at the lamp. Each of them is depositing its quantum of energy into whatever surface it strikes. And behind each of them, in the region of space they have already passed through and vacated, no new photons are arriving to replace them. That region is dark, not because darkness arrived there, because light left. The darkness advances through the room at the speed of light. But it advances the way silence advances after a sound, not as a substance moving through space, as the boundary behind which the last photons have already passed. The darkness is the wake of the departing light, not a substance traveling in the same direction. Within somewhere between 50 and 100 nanoseconds of the lamp's shutdown, every photon that was in the room at the moment of switching has completed its journey and been absorbed. No new photons have been produced to replace them. The room is dark. The transition took less than 1/10 of a microsecond, which is why it feels instantaneous to a human observer whose perceptual system operates on timescales millions of times slower. Now extend this thought experiment to a scale where the structure becomes impossible to miss. Imagine a star burning steadily 10 light-years from Earth, not 10 meters, 10 light-years, 94 trillion kilometers. For billions of years, this star has been emitting photons in all directions, and a tiny fraction of those photons have been traveling toward our planet, arriving as a faint point of light in the night sky. The stream of photons is continuous. At any given moment, photons from this star occupy every point along the 10 light-year path between the star and Earth, each one moving toward us at sea, each one carrying information about the star's luminous state at the moment it was emitted. Now, suppose this star instantaneously stops shining, a hypothetical catastrophic event, some mechanism that simply halts the nuclear furnace in a single moment, cuts off the production of new photons with no warning and no gradual decline. At the moment this happens, the situation along the 10 light-year column between the star and Earth is this. An unbroken stream of photons still stretches from the star's position all the way to Earth. Every point along that path has photons in transit. The photon at the very front of the column, the one closest to Earth, is about to arrive. The photon at the very back of the column, the last one emitted before the star went dark, is just leaving the star's surface. From Earth's perspective, absolutely nothing changes. The star continues to shine exactly as it did before, because the photons already in transit keep arriving at exactly the rate they were arriving before the shutdown. 1 second after the star goes dark, the photons arriving at Earth are ones that were emitted 1 second before shutdown, 1 light second away from the star's surface at the moment of emission. 1 year after the star goes dark, the photons arriving at Earth are the ones that were 10 light-years minus 1 light-year away from the star at the moment of emission, emitted roughly 9 years before shutdown. The star looks perfectly normal. There is no dimming, no flickering, no indication whatsoever that anything has changed at the source. This continues for 10 full years. 10 years after the star went dark, the last photon in the column arrives at Earth. It is the photon that was emitted at the final instant before shutdown, the one that was sitting at the star's surface when the nuclear furnace went silent. It makes its 10-year journey across 94 trillion kilometers of space, strikes a detector or a retina, and then nothing follows it. No more photons arrive from that direction. The point of light that has been visible in the sky for billions of years simply vanishes. One moment it is there, exactly as bright as it has always been. The next moment, it is gone. Did darkness travel from the star to Earth across 10 light-years? Over 10 years? The question deserves a careful answer because the answer is precise. Nothing traveled from the star to Earth except photons. The photons traveled at sea. They carried information about the star's state at the moment of their emission. Every photon emitted before the shutdown carried the message that the star was still shining. The last photon carried that same message because the star was still shining when it was emitted. After the last photon arrived, no further messages came. The star was gone. No more photons were coming from that direction. That direction in the sky became dark. But that darkness is not a thing that crossed 10 light-years of space. It is the end of a stream, the cessation of a flow, the word we use to describe the condition that existed along the path after the last photon had passed. Think of a river. A river flows continuously past a specific point on the bank. You can watch the water moving, measure its speed, calculate its volume per second, characterize its temperature and chemistry. The river is a physical phenomenon with measurable properties. Now imagine the source of the river, some distant glacier, instantaneously stops melting. The water already in the river continues flowing downstream at its normal speed. For a period determined by the length of the river divided by the current speed, the water at your observation point flows normally. Then the last water from before the shutdown passes your point. The river goes dry. Did dryness travel downstream from the glacier to your observation point? No. Water traveled downstream. When the water stopped, dryness was what remained. At each point the water had already passed. Dryness did not flow. Water flowed, then it stopped flowing. The dryness was the condition defined by the absence of water, and it appeared at each downstream point as the last water passed through, moving at the speed of the current. The last photon from the star moves at c. The darkness that follows it moves at c, but the darkness is not moving. The photon is moving. The darkness is what the photon leaves behind. The distinction is not semantic. It is the difference between a physical object with mass and energy and momentum traveling through space, and a condition that has none of those properties, that carries no energy and transmits no information, that is defined entirely as the absence of the physical object. This distinction becomes even clearer when you ask a specific question about information. When the last photon from the dead star arrives at Earth 10 years after the star went dark, what information does it carry? It carries the information that the star was still shining 10 years ago, at the moment of emission. That is all. The photon has no knowledge of what the star did after it was emitted. It cannot carry information about the star's shutdown, because it was created before the shutdown occurred. The information about the shutdown travels, as all information must travel, at the speed of light, carried by the last photon in the column. No information arrives before that photon arrives. No information about the shutdown travels faster than c. The darkness that follows the last photon carries no information at all. This is not a limitation of the darkness. It is a consequence of what darkness is. An absence cannot carry information the way a presence can. Silence cannot transmit a message the way sound can. The gap in a stream cannot tell you what the stream was doing before the gap appeared. Information requires a physical carrier, and darkness has no physical identity to carry anything. This asymmetry between light and darkness as information carriers connects directly to something far deeper than the physics of a single room or a single star. It connects to the reason the speed of light governs not just optics, but causality itself. The reason that nothing in the universe, not darkness, not any other phenomenon, can transmit a causal signal faster than c is not an engineering limitation. It is a structural feature of space-time, and examining it carefully reveals why the question of darkness having a speed is not just answerable, but why the answer matters for understanding what kind of universe we inhabit. But before that deepest layer, there is a detour that the physics demands we take. Because there is something that physicists have confirmed, something geometrically certain and experimentally verified, that appears at first encounter to completely contradict everything established in these last pages. There are situations where shadows, those most familiar and most visible manifestations of darkness, appear to move across surfaces faster than the speed of light. Not slightly faster, not marginally faster, dramatically, measurably, mathematically provably faster. And the resolution of this apparent contradiction does not rescue the idea that darkness has a speed. It does something far more interesting. It reveals what the speed of light actually prohibits, what it permits, and where the boundary between physical reality and geometric appearance actually lies in a universe governed by the principle of causality. That is where we go next. And it starts with a radio telescope, a distant quasar burning with the light of 1 trillion suns, and a blob of plasma that appeared to be moving at 4 times the speed of light. An observation that briefly made physicists wonder if Einstein had been wrong about everything. He had not been. But what the data actually showed was stranger than a simple violation would have been. In the early 1970s, a team of radio astronomers pointed their instruments at a distant object called 3C279, a quasar. a galaxy whose core is so energetically active, powered by a supermassive black hole consuming matter at a rate that strains comprehension, that it outshines the combined light of every star in the Milky Way by a factor of roughly 1 trillion. At a distance of approximately 5 billion light-years from Earth, 3C279 is one of the brightest radio sources in the sky, despite being so far away that the light arriving at our detectors today left its source when the universe was less than half its current age. The astronomers were not looking for anything unusual. They were conducting routine observations, mapping the structure of the quasar's jet, a narrow beam of plasma and electromagnetic radiation shooting outward from the region around the central black hole at nearly the speed of light. Jets like this are common features of active galactic nuclei, and mapping their structure over time reveals information about the physics of the extreme environment near the black hole that produces them. What they found was not routine. Over months of observation, tracking a specific blob of radio-emitting plasma within the jet, the team calculated the apparent speed at which the blob was moving across the sky. When the number came out of the equations, several members of the team checked the calculation multiple times before accepting that the arithmetic was correct. The plasma blob appeared to be moving at more than 4 times the speed of light. 4c, 4 times the absolute cosmic speed limit. 4 times the velocity that Einstein's special relativity, confirmed by half a century of experiments at that point, declared to be the maximum speed of anything carrying mass or energy in this universe. The blob was not massless. It was a physical object, a concentration of charged particles and magnetic fields with genuine mass and genuine energy, and it appeared to be cruising through space at 400% of the speed that physics said was the absolute ceiling. The discovery ignited an immediate and intense response in the astrophysics community. Papers were written, alternative explanations were proposed and demolished. The data was scrutinized for instrumental errors, calibration problems, systematic biases. None were found. The signal was real. The apparent speed was real. The question was what it meant. Had relativity been broken? Had 50 years of experimental confirmation, from particle accelerators to atomic clocks to the precise timing of planetary probes, all somehow missed a regime where the speed limit did not apply? Had the universe provided a loophole that Einstein's mathematics had not accounted for? It had not. What the astronomers had discovered was one of the most elegant geometric illusions in nature, a phenomenon called superluminal apparent motion. And understanding it requires holding 2 ideas simultaneously that human intuition wants to collapse into one: the difference between what physically happens and what appears to happen to a distant observer, the difference between physical motion and geometric projection, the difference between a real object moving through space and a pattern playing out across a surface. The plasma blob was not actually moving at 4 times the speed of light. It was moving at roughly 98% of c, aimed almost directly toward Earth. This specific combination, a very high real velocity and a very small angle to the line of sight, created a projection effect that made the transverse motion appear enormously amplified when observed from a distance. Here is how the geometry produces the illusion. The blob moves along its true trajectory through space at 98% of c. But because it is moving almost directly toward Earth, the light it emits at the beginning of its observable journey, and the light it emits later in that journey, travel nearly the same path to reach us. The light emitted later has a dramatically shorter distance to cover, because the blob has moved substantially closer to Earth during the interval between emissions. This means the 2 light signals arrive at Earth, separated by a much smaller time interval than the actual time that elapsed between their emission. The blob appears to have crossed a large angular distance on the sky in a compressed time window, making its apparent transverse speed far larger than its true speed. The specific trigonometry produces a maximum apparent velocity of approximately the true speed multiplied by the Lorentz factor for that velocity. At 98% of c, the Lorentz factor is roughly 5. Hence, the blob appeared to move at 4 to 5 times the speed of light while actually traveling below c the entire time. Every photon it emitted traveled at exactly c. The blob itself never exceeded c. The apparent superluminal speed was not a property of the object. It was a property of the observation, a consequence of the geometry between the object's direction of motion and the observer's line of sight. This was the resolution. Elegant, satisfying, and completely consistent with special relativity. The universe had not provided a loophole. It had provided a lesson in the difference between physical reality and geometric appearance. And that lesson turns out to be the key to understanding why shadows, why darkness itself in its most concrete and familiar manifestation, can appear to move faster than light without any law of physics being violated. Consider the simplest possible scenario. You are standing in an open field on a clear night. 100 meters in front of you stands a long white wall. You hold a powerful laser pointer and aim it at the left end of the wall. The beam creates a bright point of light on the surface. Now sweep the beam rapidly to the right. The bright point traces a path across the wall from left to right. The dark region ahead of the point and the shadow behind it move with the point. If the wall is long enough and your sweep is fast enough, that bright point and the shadow that accompanies it can move across the wall at any speed you choose. There is no upper limit. The speed of the point is determined by the angular rate of your sweep multiplied by the distance to the wall. You can increase either quantity without bound. At 100 meters, a quick wrist movement might move the point across the wall at several hundred meters per second. Unremarkable. But now imagine the wall is on the moon, 240,000 miles away. That same wrist movement sweeps the beam across a surface so distant that the projected point must cover thousands of miles to keep up with the angular motion. A casual flick of your wrist could move the point across the lunar surface at a speed exceeding c by a comfortable margin. The shadow trailing behind the point would move at exactly the same superluminal apparent speed. This is not a thought experiment about a hypothetical possibility. It is a description of a geometrically certain phenomenon. The mathematics is unambiguous. Given a sufficiently distant surface, the apparent speed of a projected spot, and the shadow that accompanies it, exceeds c for any reasonable angular sweep rate. This is confirmed physics. It has been observed in multiple astrophysical contexts beyond the quasar jets that first brought it to scientific attention. No serious physicist disputes it. The question is not whether it happens. The question is what it means. And what it means is something far more subtle than a violation of Einstein's speed limit. To understand why superluminal shadow motion violates nothing, you have to understand what the bright spot on the moon actually is at the physical level. Your laser pointer emits photons. These photons leave the pointer, travel through space at c, and strike the lunar surface approximately 1¼ seconds later. When the beam is aimed at a specific point on the moon, photons arrive at that point and scatter in all directions, some of them bouncing back toward Earth where your eyes can detect them, creating the appearance of a bright dot at that location. Now you flick your wrist. The beam swings to a new angle. Photons, emitted after the flick, travel along the new trajectory, also at c, and arrive at a different point on the moon 1¼ seconds after the flick. These new photons create the appearance of a bright dot at the new location. The old dot has disappeared because no more photons are being directed to the old location. The new dot has appeared because photons are now arriving at the new one. Here is the critical physical fact that makes everything else clear. The photons that created the dot at position A are entirely different physical objects from the photons that created the dot at position B. No individual photon traveled from A to B along the surface of the moon. Every single photon traveled from the laser pointer to the moon in a straight line through space at c. The dot at A was made by one set of photons. The dot at B was made by a completely different set. The apparent motion of the dot across the moon's surface is not a physical object moving across a surface. It is a sequence of independent events, photon arrivals, occurring at different locations in rapid succession. The shadow trailing behind the dot is the region where photons from the laser are not currently arriving. When the dot moves from A to B, position A becomes dark, not because darkness traveled from somewhere to position A, but because photons stopped being directed to position A. The cause of the darkness at A is a change in the laser pointer's angle happening back on Earth. That causal signal travels from Earth to position A through space at c, carried by the cessation of photon arrivals. The darkening at position B when the dot moves onward follows the same independent causal chain. The pointer changes angle again. Photons stop arriving at B. B goes dark. No causal signal travels along the moon's surface from A to B at superluminal speed. The shadow does not carry information from A to B. Each point on the surface receives its own independent instructions from the laser pointer through photons traveling at C. The shadow is not a causal chain. It is a pattern of independent responses to a changing geometric configuration happening at the source. The analogy that makes this clearest involves theater marquee signs. Those signs where rows of light bulbs switch on and off in sequence to create the illusion of a bright region sweeping smoothly across the display. Watch the pattern, and it appears to move continuously from left to right at whatever speed the timing circuit dictates. But nothing physical moves from left to right. Each bulb turns on independently in response to its own electrical signal from the central controller. The bulb on the left has no causal connection to the bulb on the right through the apparent motion. They are connected only through the controller that triggers them in sequence. The apparent motion is a pattern, an artifact of sequential timing, not a physical displacement. You could make the pattern sweep across the marquee at any speed whatsoever. Simply adjust how quickly the controller triggers successive bulbs. Make the triggers fire faster, and the pattern moves faster. There is no speed limit on the pattern because the pattern is not a physical object. No mass moves from left to right. No energy transfers from bulb to bulb in the horizontal direction. Each bulb receives its energy vertically from the electrical circuit beneath it. The horizontal motion is pure geometry. The dot on the moon works identically. Each point on the lunar surface receives its photons through its own independent connection to the source, a straight line through space at C. The lateral motion of the dot across the surface is pure projection. No energy travels horizontally along the moon's surface from point A to point B. No information passes between the 2 points through the moving dot or the moving shadow. The shadow trailing behind the dot is the geometric footprint of an absence of photons, and that absence has no physical substance to transmit from one location to another. This is why the entire framework of speed, velocity, and propagation applies to the apparent motion of shadows only in the geometric sense, not in the physical sense. Apparent speed is a property of a pattern. Physical speed is a property of an object. A pattern can have any apparent speed because patterns are not constrained by the physics that governs the motion of objects through space. Objects carry mass, energy, and causal influence. Patterns carry none of these things. The speed limit on physical motion is a speed limit on the transmission of mass, energy, and causal influence. It is not a speed limit on the movement of geometric relationships between objects. The definitive test of whether something is genuinely moving faster than light or merely appearing to is simple. Can it transmit information between 2 points faster than a photon could travel directly between them? If yes, causality is violated and the phenomenon is physically forbidden. If no, it is physically permitted, regardless of how fast it appears to move. Apply this test to the shadow sweeping across the moon. Station one observer at position A and another at position B. Can the shadow's arrival at B tell the observer there anything about what the observer at A is doing or thinking or trying to communicate in less time than a light signal could travel the distance between A and B across the lunar surface? The answer is no. The shadow's arrival at B tells the observer there only that the laser pointer on Earth is now aimed at their location. It tells them nothing about position A. The causal chain runs from Earth to B, not from A to B. The shadow cannot carry a message between the two observers because the shadow is not connected to either of them in the way a physical signal would need to be. The shadow moves faster than light. But it moves faster than light the same way that the intersection point of 2 closing scissors blades can move faster than light, the same way that the point where an ocean wave breaks against a long beach can move faster than the wave itself travels through the water, the same way that a pattern of illumination on a screen can sweep faster than any physical object. None of these phenomena transmit information faster than light. None of them create causal shortcuts between separated points in spacetime. None of them violate the principle that the speed of light is the speed of causality. And darkness, the absence that sweeps across a surface in the shadow's wake, participates in exactly the same exemption for exactly the same reason. It is not a physical substance moving through space. It is a geometric pattern of photon absence playing out across a surface, where each point independently receives or fails to receive photons through its own light speed connection to the source. The darkness has no physical substance to transmit. It has no energy to carry. It has no information to deliver. It is the condition that remains at each point after the last photon from the source has passed through. This is the complete physical picture of superluminal shadow motion. And it does not rescue the idea that darkness has a speed. It does something more valuable. It clarifies exactly what the speed of light governs, what it permits, and where the line between physical reality and geometric appearance is drawn in a universe where causality is the deepest law. That deepest law, the principle that the speed of light is really the speed of causality itself, the maximum rate at which any event can influence any other event anywhere in the universe, is where this story reaches its most profound layer. Because understanding it changes not just how you think about shadows and dark rooms and distant stars, it changes how you understand why the universe has a history, why there is a before and an after, why causes precede effects, why reality unfolds as a sequence of events rather than existing all at once in a single timeless state. Darkness has no place in that architecture, and understanding why it has no place reveals more about the structure of space-time than almost any positive fact about light itself. That is where nocturnal space goes next. And if this particular kind of thinking, the kind that starts with something ordinary and follows it somewhere genuinely strange, is what brought you here tonight, then stay. Subscribe to the channel. Turn the notifications on. Because the next layer of this story is the one that makes physicists pause before they answer, the one about light cones and causal horizons and the reason the night sky is dark at all. The shadow has moved faster than light, and nothing has been violated. The question is why? And the answer is the deepest thing physics knows. There is a number that appears in the equations of modern physics with a frequency and a centrality that no other constant matches. It shows up in Maxwell's equations describing electromagnetism. It shows up in Einstein's field equations of general relativity describing the curvature of space-time under the influence of mass and energy. It shows up in the equations of quantum electrodynamics describing the behavior of light and matter at the subatomic level. It shows up in the formula for the energy released in nuclear reactions, in the equations governing the propagation of gravitational waves, in the mathematics of black hole thermodynamics, in the theoretical framework describing the earliest moments of the universe's existence. The number is c, the speed of light. But here is the thing that most people who have encountered this number in popular science never quite absorbed. The reason c appears in all of these places is not because all of these phenomena happen to involve light. Gravitational waves have nothing to do with light. Nuclear reactions do not produce photons as their primary output. The curvature of space-time around a massive object is not caused by anything electromagnetic. The reason c appears in all of these equations is not because they all describe light. It is because they all describe causality. c is not the speed of light in any fundamental sense. Light happens to travel at c because light is a massless phenomenon, and all massless phenomena travel at c. But c itself is something deeper and more fundamental than the speed of any particular thing. c is the speed at which cause connects to effect across the fabric of space-time. It is the maximum rate at which any event anywhere in the universe can reach out and influence any other event anywhere else. It is the cosmic clock speed, the processing rate of reality itself, the parameter that determines how fast the universe can know about itself. Understanding this distinction between c as the speed of light and c as the speed of causality is the key that unlocks everything that has remained puzzling about shadows and darkness, and the question that started this entire investigation. And it begins with a piece of mathematics that at first glance appears to be pure abstraction, but turns out to describe something as concrete and physical as the walls of the room you are in. In 1908, 3 years after Einstein published Special Relativity, a mathematician named Hermann Minkowski delivered a lecture that opened with one of the most consequential sentences in the history of physics. He declared that henceforth space by itself and time by itself were doomed to fade into mere shadows, and only a kind of union of the two would preserve an independent reality. He was not speaking metaphorically. He had discovered, working through the mathematical implications of Einstein's postulates, that space and time were not two separate things that happened to coexist. They were two aspects of a single four-dimensional geometric structure, a structure he called space-time. In ordinary three-dimensional space, the distance between 2 points is calculated using the Pythagorean theorem extended to 3 dimensions. The square of the distance equals the sum of the squares of the differences in each spatial coordinate. Minkowski showed that in four-dimensional spacetime, the interval between two events, the spacetime analog of distance, was calculated using a modified version of this formula where the time coordinate contributed with the opposite sign from the spatial coordinates. This seemingly minor mathematical adjustment, a change in the sign of one term in an equation, has consequences that reshape the entire nature of physical reality. The most profound of those consequences is the light cone. From any event in spacetime, you can construct a geometric structure called a light cone. Imagine the event as a point. From that point, light radiates outward in all three spatial directions at c. As time passes, the sphere of light expands. If you plot this expanding sphere against the time axis, the boundary of the sphere at each moment traces out a cone shape in the four-dimensional diagram. This is the future light cone of the event. It represents every point in spacetime that light from the original event could possibly reach, and therefore every point in the universe that the original event could possibly influence. Inside the future light cone lies every location and every future moment that the event can reach. These are the points that the event can causally affect. A message could be sent there. A force could be felt there. A gravitational wave could arrive there. The event's influence is physically capable of reaching these points, because a signal traveling at or below c emitted from the event could make the journey in the available time. Outside the future light cone lies everything the event cannot reach, not merely far away in the practical sense, not merely difficult to reach given current technology, physically, structurally, geometrically unreachable. The event's influence cannot propagate to points outside its future light cone, because doing so would require a signal faster than c. And the universe does not permit signals faster than c, not as an engineering limitation, not as a practical constraint, but as a feature of the geometric structure of spacetime itself. The equations of physics written in Minkowski's four-dimensional framework simply do not have solutions corresponding to causal signals propagating outside the light cone. The mathematics forbids it at the most fundamental level. The past light cone works in the same way, but in reverse. Every event has a cone reaching backward in time, encompassing every point in the past from which a signal traveling at or below c could have originated and reached the event. These are the points that could have causally influenced the event. Everything outside the past light cone is causally disconnected from the event in the past. No signal from those points could have arrived in time. Their history is inaccessible, unable to have influenced anything at the event's location. This structure, the light cone as the boundary of causal influence, is not a theoretical construction imposed on top of physics. It is embedded in the geometry of spacetime. It is what spacetime is. Every event in the universe, every moment of every physical process at every scale from subatomic to cosmological, is surrounded by its light cones. The future cone defines what can be affected. The past cone defines what could have been the cause. The region outside both cones is causally isolated, disconnected, unable to send or receive influences. And c determines the angle of the cone. If c were larger, the cones would be wider, allowing events to influence more distant regions in a given amount of time. If c were smaller, the cones would be narrower, restricting causal influence to smaller regions. The specific numerical value of c, 299,792 kilometers per second, literally determines the shape of cause and effect across the entire universe. It is the architectural constant of reality. This framework is not abstract. It has been tested and confirmed by observations of such clarity and precision that the scientific community treats it as established beyond meaningful doubt. The most spectacular single confirmation came on August 17, 2017. At 12:41 Universal Time, gravitational wave detectors at the LIGO facilities in Louisiana and Washington State and the Virgo detector in Italy registered a signal, a ripple in the fabric of space-time, produced by a cataclysmic event 130 million light-years away. Two neutron stars, each more massive than the Sun but compressed to the size of a city, had been spiraling toward each other for hundreds of millions of years, losing energy to gravitational radiation, drawing closer with each orbit, until they finally collided in a violent merger lasting fractions of a second. The gravitational waves from that merger traveled outward at the speed of light, spreading through space-time as ripples in its geometry, crossing 130 million light-years of intergalactic space, and arrived at Earth's detectors. 1.7 seconds later, gamma-ray telescopes in orbit detected a burst of electromagnetic radiation from the same location in the sky. Two independent signals, one a ripple in space-time geometry, and one a burst of photons, both produced by the same event, had traveled 130 million light-years and arrived within 1.7 seconds of each other. 1.7 seconds after 130 million years of travel. An agreement so precise, across such an incomprehensible distance, that it confirmed something physicists had assumed but never directly measured. Gravity and light propagate at exactly the same speed. Gravitational waves travel at c, not approximately c, not close to c, but c to within 1 part in a million billion, based on the precision of that measurement. This single observation established something of profound importance. The universe has one speed of causality, not two, not several. One. Whether the messenger is a photon or a gravitational wave, whether the force being transmitted is electromagnetic or gravitational, whether the signal is a burst of light or a ripple in the geometry of space-time itself, the maximum delivery speed is c. The causal architecture of the universe is unified around a single constant, and this is where the question of darkness, which has been following us through every layer of this investigation, finds its deepest and most complete answer. Darkness has no speed because darkness has no place in the causal architecture of space-time. The light cone framework describes how events influence each other through the propagation of physical signals. Photons carrying electromagnetic force, gravitational waves carrying space-time curvature, particles carrying mass and energy. These are the entities that participate in causal exchange. These are the things that travel from the interior of one light cone to the interior of another, establishing the connections that make physics possible. Darkness is not a signal. It is not an event. It does not appear on any space-time diagram as a point from which causal influence radiates. There is no light cone emanating from darkness, because darkness is not something that happens. When a region of space becomes dark, the causal explanation always traces back to an event involving light. The source switched off. An obstacle blocked the photon path. A star exhausted its fuel and collapsed. These are the events, the occurrences that generate light cones and project their influence forward through space-time. The darkness at the observation point is the effect, the consequence of photons ceasing to arrive. And the causal connection between the triggering event and the resulting darkness travels at c, carried by the last photons in transit, or by the gravitational and electromagnetic signals associated with the source's shutdown. The shadow sweeping across a surface at apparent superluminal speed does not create new light cones connecting points along the shadow's path. Each point on the surface has its own independent causal connection to the light source, established by the photons that either arrive or fail to arrive, each traveling at c. The shadow is not a causal chain propagating laterally across the surface. It is a pattern of independent responses to a changing geometric configuration, and patterns do not create causal connections. They are the visible result of causal connections that were already there, each running independently from source to surface at c. Think about what it would mean for darkness to have a genuine causal speed. It would mean that the absence of photons at one location could cause the absence of photons at another location through some mechanism of propagation. But the absence of a photon has no mechanism. It has no energy to drive a process. It has no field to mediate an interaction. It has no particle to carry an influence. Absence is the lack of all these things. The question of how fast an absence propagates is equivalent to the question of how fast nothing moves. And nothing, by definition, does not move. This has measurable consequences that extend far beyond optics and shadows. Consider quantum entanglement, one of the most discussed and most misunderstood phenomena in modern physics. When two particles are entangled, measuring the state of one instantly determines the state of the other, regardless of the distance between them. This correlation is real and has been confirmed in experiments of extraordinary precision. Einstein found it deeply troubling and called it spooky action at a distance. It appears at first encounter to involve an influence propagating instantaneously between the two particles, which would violate the causal speed limit. But careful analysis reveals that no usable information travels between the particles. You cannot control which outcome your measurement produces. You cannot encode a message in the result. The distant particle's state correlates with yours, but you cannot exploit that correlation to communicate. To extract any meaning from the correlation, you need to compare the two measurement results through a conventional communication channel, and that channel operates at or below C. Entanglement creates correlations without creating communication. Causality remains intact. The speed limit survives even the bizarre domain of quantum mechanics. At the largest scale, the causal structure of spacetime creates the observable universe itself, a sphere of space from which light has had time to reach Earth since the cosmos began. The radius of this sphere is approximately 46.5 billion light-years, larger than the 13.8 billion light-years the universe's age might suggest because space itself has been expanding throughout cosmic history, carrying distant objects to greater distances even as their light traveled toward us. Beyond this sphere lies space that almost certainly exists, but from which no signal, no photon, no gravitational wave has had time to reach us. These regions are causally disconnected from our location. The darkness we observe in the direction of those regions is not a substance that has traveled to us from some dark source. It is the absence of any causal connection between our location and those distant places. The darkness is the geometry of space-time speaking in the only language it has available when nothing has bridged the gap. Silence where no signal has arrived. And the expansion of space adds a dimension to this causal isolation that carries a strange beauty when you follow it to its conclusion. Distant galaxies recede from us at speeds proportional to their distance, carried not through space but by the expansion of space itself. Beyond a threshold distance known as the Hubble radius, roughly 14 billion light-years, the recession velocity exceeds c. Galaxies beyond this distance are being carried away faster than light can bridge the gap. The darkness in the direction of those galaxies is not the darkness of empty space. It is the darkness of a causal horizon, a boundary beyond which no signal can ever reach us again, a region that has crossed permanently outside our future light cone. In roughly 100 billion years, the accelerating expansion of space will have carried virtually every galaxy beyond our observable horizon. The night sky will be empty, not sparse, empty. Every galaxy beyond our local group will have been swept past the causal boundary. The cosmic microwave background, the ancient glow from the first moments of the universe that currently fills the sky with detectable radiation, will have redshifted into silence. Future astronomers in that distant era will look outward and see nothing. No distant galaxies, no evidence of cosmic expansion, no trace of the Big Bang. The universe will have pulled its own history beyond the light cones of every observer within it. Those future scientists might conclude that their galaxy constitutes the entire universe. They would have no way to discover cosmic expansion because there would be no distant galaxies to observe receding. They would have no way to infer the Big Bang because the evidence would have been carried beyond detection. They would have no way to measure dark energy because there would be no cosmic structure to reveal its effects. Their cosmology would be completely wrong, not through any failure of intelligence or method, but because the universe would have placed the evidence outside their causal reach. The darkness they would observe surrounding their island galaxy would not be a substance. It would be the causal horizon itself made visible, the geometric boundary of what C and the finite age of a universe under accelerating expansion allow any observer to know. The darkness would be the shape of ignorance imposed by the structure of space-time. That is what darkness is, at every scale from a switched-off lamp to the edge of the observable universe. Not a substance, not a thing with speed or energy or causal power. the condition that exists wherever the universe has not yet managed to bridge the gap, wherever no photon has traveled, wherever no gravitational wave has rippled, wherever no causal signal of any kind has made the journey from there to here. And what that reveals, when you hold it clearly, is something that inverts the entire intuitive relationship between light and dark that human beings carry from birth. Because if darkness is the default, if darkness is what space-time looks like when no causal connection has been established, then light is something far more remarkable than the obvious, ambient, everywhere present condition your brain has always treated it as. Light is the exception. That inversion is where this story ends. And it changes everything about how a dark room feels at the end of a long night. There is an assumption so deeply embedded in the human experience of existence that most people never notice it is there. It operates below the level of conscious belief, beneath the reach of ordinary introspection, woven into the fabric of how the brain processes every moment of waking life. The assumption is this: light is normal. Light is the baseline condition. Light is what the universe looks like when everything is working as it should. And darkness is the deviation, the interruption, the thing that requires explanation. The shadow on the wall, the power outage, the moonless night. These are departures from the expected state. The expected state is brightness. Physics says the opposite is true, not as a matter of perspective or framing or philosophical preference, as a matter of confirmed, measured, observationally verified physical fact. The universe is overwhelmingly, almost incomprehensibly dark. And darkness is not the deviation. Darkness is the ground state, the default, the condition that exists everywhere the universe has not made the extraordinary effort to establish a causal connection through the emission and transmission of light. Consider the geometry of the observable universe, the sphere of space from which light has had time to reach Earth since the cosmos began spans approximately 93 billion light-years in diameter. Within that sphere, matter is distributed in a structure of almost fractal complexity. Galaxies arranged in filaments and walls surrounding enormous empty regions called cosmic voids. The filaments and walls contain the galaxies. The voids contain almost nothing. And the voids, those vast dark regions where matter is so sparse that a cubic meter of space might contain fewer than a handful of atoms, make up roughly 80% of the observable universe by volume. 80%. The overwhelming majority of the observable universe, by volume, is dark empty space where the density of matter is so low that stars cannot form, where galaxies do not exist, where the nearest photon source is so distant that for any observer hypothetically situated in the void, the night sky would be dramatically darker than what we see from Earth. And even on Earth, surrounded by the dense stellar environment of the Milky Way, even here where we have the luxury of a star 8 light-minutes away, the night sky is dark. The stars are points. The space between them is black. The darkness between the stars is not a background that the stars are painted on. It is the dominant feature of the sky, interrupted here and there by rare, scattered, precious points of light. This is the universe as it actually is, not as human intuition presents it, lit and warm and filled with the ambient glow that evolution trained the brain to treat as normal, but as physics describes it, vast and cold and almost entirely dark, with light occurring as a local, temporary, energy-expensive exception in certain small regions where nuclear physics has conspired to ignite a fusion reaction and sustain it long enough to fill the surrounding space with photons. Every star you have ever seen in the night sky is a nuclear furnace, an object so massive that its own gravity has compressed its core to the point where hydrogen nuclei fuse into helium and release energy according to the most famous equation ever written. That process requires specific conditions that are extraordinarily rare in the universe: the right density of hydrogen, the right temperature, the right gravitational pressure, the right chemical environment left over from previous generations of stellar evolution. Stars are not the normal condition of matter in the universe. They are the exception, the exotic edge case, the unlikely outcome of a very specific set of circumstances that most matter in the universe never experiences. The photons those stars emit, the light that crosses the void between them and arrives at your eyes on a clear night, are even rarer. A photon produced in the core of a star must survive a random walk through the stellar interior, lasting potentially hundreds of thousands of years before escaping into space. Then it must travel in the right direction to intersect with the vanishingly small cross-section of a planet's surface, at precisely the right moment to encounter a detector or a retina capable of registering its arrival. The probability of any given photon completing this journey and being observed is extraordinarily small. Most photons travel through the universe forever, without ever encountering anything that absorbs them, redshifting as space expands beneath them, their energy diluting across an ever larger volume until they are effectively undetectable. Light connecting 2 points across the universe is not the expected condition. It is a remarkable coincidence, a causal bridge thrown across an ocean of darkness by a process of almost improbable specificity, and yet your brain, shaped by 3.5 billion years of evolution, on the sunlit surface of a planet orbiting one of those nuclear furnaces, at a distance precisely calibrated to keep liquid water stable, treats that bridge as the obvious, unremarkable default state of things, the water in which the fish swims, the air the bird flies through, so ambient as to be invisible. The question we began with, whether darkness has a speed, was always going to lead here, because the question contains, buried inside it, the assumption that darkness is something that arrives, something that travels, something that does. An assumption that treats darkness as the active participant and light as the passive condition it replaces. And following that assumption all the way down to its physical foundations reveals that the assumption is perfectly backwards. Light is the active participant. The photon is the thing that travels, that does, that carries energy and information and causal influence across the void. Darkness is what was already there, what has always been there. What is there in every region of the universe where a photon has not made the journey? There is an old puzzle in cosmology that captures this beautifully. It is called Olbers' paradox, formalized by the German astronomer Heinrich Olbers in 1823, though the essential question had troubled thinkers for 2 centuries before him. The paradox is simple to state. If the universe is infinite and eternal and uniformly filled with stars, then every line of sight in every direction should eventually terminate on the surface of a star. Look in any direction and eventually a star is there, at some distance. The sky should therefore be uniformly bright in every direction, as blindingly luminous as the surface of the sun, because every point in the sky has a star behind it at some remove. The night sky is obviously not uniformly bright. It is dark, punctuated by points and patches of light against a black background. Olbers' paradox asks why. The resolution involves several factors, but the most fundamental is the finite speed of causality and the finite age of the universe. The cosmos is approximately 13.8 billion years old. Light has been traveling for at most 13.8 billion years, since the universe became transparent to photons, roughly 380,000 years after the Big Bang. Stars beyond a certain distance, currently about 46 billion light-years accounting for expansion, are beyond our past light cone. No photon from them has had time to reach us. We cannot see them. They exist outside our causal horizon. The night sky is dark because the universe has a finite age and light has a finite speed, which means there is a maximum distance from which starlight could have reached us. Beyond that distance, the universe is causally silent. No photon has made the journey. No causal connection has been established. The darkness you observe between the stars is not empty in a trivial sense. It is geometrically, causally empty. It is the visual representation of a boundary beyond which the universe has not yet had time to reach out and touch this location with light. Every dark patch in the night sky is a window into the causal structure of space-time, a direction in which no photon has arrived from sufficient distance to be visible, a region where the light cone of every distant star has not yet intersected with your location. The darkness is the geometry of cause and effect made visible, made absence. Every dark gap between the stars is telling you something precise and physical. No causal signal from that direction, from beyond a certain distance, has reached you yet. You are looking at the edge of what the universe has been able to communicate to you in the time it has been running. Now, look at a point of light. any star. Pick one. The bright one almost directly overhead on a clear night, or the faint smear of the Milky Way at the horizon, or a galaxy visible as a dim patch in a dark sky far from city lights. That light made a journey. It left a nuclear furnace, survived the random walk through a stellar interior, escaped into space, traveled across a distance measured in light years or light millennia or light millions of years, threading through the vast dark void between galaxies, arriving at the precise moment and location where your eye happened to be open and pointed in the right direction. That arrival is not normal. It is not the expected condition. It is a causal connection, a thread thrown across an ocean, a bridge built by physics between two points that would otherwise have no knowledge of each other's existence. The photon that reaches your retina was created in a specific nuclear reaction at a specific moment in the interior of a specific star. It has been traveling ever since. It has crossed distances that would require millions of human lifetimes to traverse even at the speed of light. It has passed through regions of space where no matter exists to interrupt it, where the temperature is 3 degrees above absolute zero, where the density of particles is lower than any vacuum achievable in a laboratory on Earth. And it arrived, at your eye, at this moment. After a journey that is, when you follow its full length and duration, one of the more remarkable physical events occurring in your immediate vicinity. The darkness surrounding that point of light is not the remarkable thing. The darkness is what was always there. The remarkable thing is the light, the causal connection, the photon that made it. And this inverted perspective, once you have absorbed it, does something irreversible to the experience of darkness. Not the emotional experience, the physical alertness, the heightened awareness, the evolutionary response to the absence of visual information. Those remain exactly as vivid as they have always been. But the conceptual experience changes. The dark room is no longer a room that darkness has filled. It is a room where photons are no longer arriving. The dark sky is no longer a backdrop painted behind the stars. It is the causal horizon of the universe, the region beyond which no signal has bridged the gap, made visible by the absence of the bridges that have been built elsewhere. The darkness between galaxies is not a substance separating them. It is the default state of spacetime in regions where the extraordinary, unlikely, energy-expensive process of stellar nuclear fusion has not established a local source of photons. Darkness has no speed because it does not travel. It does not travel because it is not a thing. It is not a thing because it has no physical properties, no mass, no energy, no momentum, no causal power of any kind. It is the condition that exists wherever the universe's most remarkable messenger, the photon, traveling at the only speed the vacuum allows, has not yet arrived or has already departed. It is the silence between the signals, the blank page before the writing, the ocean through which rare causal bridges are thrown by the extraordinary physical processes we call stars. The next time you lie in darkness and feel it surrounding you, consider what is actually there. Not a substance, not an entity, not a thing with speed or direction or physical identity. An absence, specifically the absence of photons. And consider what that absence means at the scale of the universe. You are in a region of space where the causal connections available to you, the photon bridges linking you to the nuclear furnaces scattered across the void, have temporarily been reduced or eliminated. The star outside your window has set below the horizon. The lamp has been switched off. The photons have departed or are being blocked. And what remains is the default, the ground state of the universe, the condition that covers 80% of observable space by volume. The darkness that Olber's paradox revealed to be not an absence of stars, but an absence of causal history. Not emptiness in a trivial sense, but the geometric boundary of what the universe has had time to communicate. Darkness does not rush in when light departs. Darkness was always there, waiting behind the photons the way silence waits behind every sound, the way cold waits behind every source of heat, the way the void waits behind every arrangement of matter that has briefly, miraculously, organized itself into something complex enough to generate light and ask questions about it. The speed of light is not a limit on how fast photons happen to move. It is the speed at which the universe processes itself, the rate at which cause connects to effect, the architectural constant that gives space-time its geometry and reality its sequence. Everything that participates in that architecture, every photon, every gravitational wave, every particle carrying force or mass or information, obeys that speed because the alternative is not merely difficult or expensive. The alternative is incoherent. A universe without c as the speed of causality is a universe without before and after, without sequence, without history, without the arrow of time that makes the concept of physics meaningful. Darkness participates in none of this. It has no speed because it has no architecture to travel through. It has no causal power because causality requires a carrier, and it is not one. It has no place in the equations of physics because the equations of physics describe what exists, and darkness does not exist. It is what remains when existence, in the form of photons, has moved on. And the fact that you ask the question, that you wanted to know whether darkness has a speed, that you followed the question through everything it connects to, through the nature of light, and the history of physics, and the geometry of space-time, and the causal architecture of the universe, and the paradox of the dark night sky, and the fate of the observable universe in 100 billion years of accelerating expansion, that pursuit is itself one of the most remarkable things happening in this region of space. A universe that is mostly dark, overwhelmingly silent, almost entirely absent of the causal connections that constitute information and knowledge and understanding, has in at least one location produced an arrangement of matter complex enough to ask why the dark places are dark, and to follow the answer all the way down to where it lives. That is light, not the photon kind, the other kind, the kind that has no speed because it does not travel through space at all, the kind that the darkness, whatever it is, has never managed to extinguish. If this is the kind of thinking that finds you at the end of a long night, that patient pursuit of the obvious until something extraordinary appears underneath, then nocturnal space is where you belong, is where you... Every video on this channel is built the same way this one was. Start with a question that sounds simple. Follow it somewhere most people never go. And end somewhere that changes how the dark feels when the lights go out. Subscribe to Nocturnal Space. Turn on notifications so nothing passes you while you sleep. And if this video found you in the quiet hours, with the room dark around you and the question still turning in your mind, leave a single word in the comments. Leave the word light. Just that. So we know you made it all the way to the end. So we know you heard it. The universe is almost entirely dark. And that darkness has no speed, no substance, no physical identity of any kind. It is the default, the canvas, the ocean. You are the exception.